So today's lesson on compound interest is an expansion of what we covered today in class. Today in class we talked about exponential growth and decay functions that can be used in the real world. We basically covered modeling of exponential growth and decay using the formula y equals a times 1 plus or minus r to the t power. This is our growth or decay function depending on plus or minus, and it's used for all sorts of real-world problems including bacteria, as we saw in class, record album sales, debt, etc. So exponential growth functions are used in real-life situations involving compound interest. Compound interest is interest paid on the initial investment called the principal. And on previously earned interest. So basically what this is saying is that I put money into an account, that first set of money that I put in, that is my principal amount. That's my initial investment. And then I'm going to get paid an interest, each time period, whatever it may be. And that's going to be adding on to the amount of money in my account. So interest paid only on the principal is called simple interest. We've seen simple interest before. You learned it probably in middle school, whether you realize it or not. This was the formula I equals PRT, principal times rate times time. So just to compare the two, simple interest would be I put money into an account, my principal amount, I'm getting paid 2% per year. And every year, I'm getting 2% of that initial amount. Compound interest is like a bank account where you put in your principal amount, that's the amount that you deposited, and then you make, let's say, 2% interest on what's in the bank account. So every time you get paid a little bit more in interest, that amount that you're going to get is going to increase because you're getting just a little bit more interest every time because the bank account is growing larger and larger. So although interest earned is expressed as an annual percent, the interest is usually compounded more frequently than once per year. Therefore, our original formula that we were talking about today with the growth factor, this exponential growth model, it must be modified for compound interest problems. So here, this is our important formula, compound interest formula. A equals P times 1 plus R over N to the NT power. Let's discuss what this means. So we have our formula, and as we learned today, P, that's the principal amount. It's our initial investment. It's our starting amount. Next we have R. We studied R today as well. That is our rate, our interest rate. I should write interest rate. And what is it always written as? It's always written as a decimal. Next we have N. N is our new vocabulary. It represents the number of compounding periods. Ooh, sorry. Let me rewrite that. Periods. It is the number of times per year that we are getting an interest. Number of times per year being compounded. Next we have T. T is time. That's representing my time, and it's usually going to be in years. And finally, we have A. That's what we're solving for. That's our balance. That's our amount in the account after X amount of years. So amount in account over time. The most important part that I find students struggle with most is understanding the compounding periods. I cannot emphasize this enough. You need to know this vocabulary. If they talk about compounding annually or yearly, we are talking about one time per year. So every year you get whatever the interest rate is. Semi-annually, that's like a semicircle, that's half a circle. That's going to be 2 times per year. So every 6 months you get your interest. Quarterly is 4 times per year. There's 4 quarters in a dollar. It's just one way to remember it. So 4 times a year. Hopefully monthly, you already know this, 12 times per year. 1 time a month, 12 months in a year. This is monthly. Daily, that's 365 days. So, 365 days in a year. So that's 365 times per year. I'm sure there's someone out there right now thinking to themselves, well, what about leap year? Because I know this year's leap year. We're going to go with our basic 365 times a year. And finally, there's continuously. We're not going to worry about continuously right now. Continuously is going to deal with E, which is what we are going to be studying in the next part of this unit. So don't worry about continuously right this second. I want you to ignore it. But do understand that there will be compounding continuously. So let's take a look at this example. Suppose you invest $1,050 at an annual interest rate of 5.5%. Find the amount you will have in the account after 5 years if the interest is compounded with the given frequency. So let's look at one together. We have our formula, A equals P times 1 plus R over N to the NT. What we need to know, and this is going to apply to every single one of these sections of this problem, P is our principal amount, our starting amount. That's $1,050. And I highly recommend that you write this out and you have it on the side so that you know what to plug in. Then we have R. R is our interest rate. That's 5.5%, but what did we say? We do not keep interest rate at a percent. We're going to change it to a decimal, so 0.055. And then we have find the amount you will have in the account after T years. So T is going to be 5 years, because after 5 years, if the interest is compounded with the given frequency. So let's plug these in and then use our calculator. A equals 1,050 times 1 plus R over, what is our R? Our R is 0.055 over N. What is our N? We're compounding monthly. That means N equals 12. So we're going to plug in 12 here, and then 12 times T, which is 5. Use your calculator. You can plug this in. We get 1,050 times 1 plus something like 0.004, blah, 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 times, or to the power of 12 times 5, which is 60. My advice would be to take your graphing calculator and do this all at once. Make sure you use correct parentheses, but you can just plug it in, and you should get, in the end, now remember we're talking about dollars, so $1,381.49. All right. right, if we look at quarterly here says we are compounding at 4 times a year. So we're going to plug in everything to be the same. A equals 1,050 times 1 plus 0.055. But now I'm going to be dividing by 4, and then I'm putting it to the power of 4 times 5. So if you put this all in together, you should get hopefully a final answer of, now I want you to pause the video, see if you can find the answer. All right, hopefully you got an answer of $1,379.77. If you got that, great. If not, go back and make sure that you put in parentheses, or go back and do one step at a time. First, do 0.055 divided by 4, then add 1, then put it to a power of 20, and then finally multiply it by 1,050. All right, I want you to pause the video and try part C on your own, daily. Think about what n means and then plug it into the formula. All right, hopefully you did this and you said n equals 365. So if we plug that into our formula, we have 1,050 times 1 plus 0.055 divided by 365 to the power of 365 times 5. Put that all in your calculator and you should get an answer of $1,382.33. Very good. So for example 2, you invest $1,300 at an annual interest rate of 4.3% compounded quarterly. Find the amount you will have in the account after 3 years. As I said before, let's list out all the information we know. We know P is our initial amount, our principal amount. That's going to be $1,300. Then we know we're given R. R is 4.3%. However, R has to be left as a decimal, so 0.043, because you're dividing by 100. And then we're told it's compounded quarterly. That's our N, and quarterly means 4 times a year, so N equals 4. Finally, they want to know what A is in the formula P times 1 plus R over N to the NT power. Well, they want to know after 3 years, so our T is going to be 3. So pause the video, solve this problem, and let's see what you get. All right, we want to find A. Our principal amount is $1,300. 1 plus 0.043 divided by 4 to the 4 times 3 power. Assuming you did this and you put it in your calculator, you should get $1,477.98. Very good. Our last problem is how much must you deposit in an account that pays 2.75% interest compounded annually to have a balance of $14,500 after 10 years. All right, so they want us to find what we need to initially deposit. So we don't know what P is. But they do tell us that R is 2.75%. Written as a decimal, that's 0.0275. And they said it's compounded annually. That means once a year, so N is going to equal 1. They want to know how much will you have to deposit, what is P, if we have a balance at the end. So A is going to be $14,500 after T, which is 10 years. So use the same formula. A equals P 1 plus R over N to the NT power. And let's start solving. We have 14,500 equals, we want to know what P is, 1 plus 0.0275 divided by 1 to the nt to the 1 times 10 power. Well, 14,500 equals p to the 1.0275 to the 10th power. Having done this, to find p, we're going to take 1.0275 to the 10th power and divide it on both sides. This tells me my p is 14,500 divided by 1.0275 to the 10th power, which is approximately $11,054.77. So hopefully you've been exposed to a couple of problems now involving compound interest. Make sure that you understand what each letter or variable of the formula means. Make sure you understand what the formula is. And definitely make sure you understand the different types of compounding, because you're going to have to know this stuff for the quiz and test. Good luck.